Hello there, it's Jay here from Jay's Vintage Junk, and yeah, I know it's a bit sooner than I said, but I'm just really intrigued to see whether I can actually get this thing to do something. So what I thought we'd do in this video is we'll actually crack in it and have a quick look. Have a look inside, see if we can actually figure out what is wrong with it. It's probably going to be capacitor related, if I'm honest. But I've never had this thing open, so it'd be nice to just have a look, a general look around inside it anyway. Hopefully it's not got some nasty CMOS battery in there that's, in fact that's a good point. With the age of this, like I say, it's probably very late 80s, early 90s. It could very well have a one of them Vtech barrel cells for its BIOS battery, in which case they are known for leaking. Now that one won't come out, so I'm wondering whether the standoff oh, I've missed one there. And we have various different lengths and styles of screw as well, which makes putting it back together fun. That's loose there, that's where that's broken. I'm guessing the bottom comes off rather than the keyboard coming out. Get that. That's come out. Let's try tipping it over. Yeah, that's that one out. That might just be the disk drive though. Right, now let's figure out how this thing's going to come apart. There we go. We just needed a little bit of persuasion. So where is the main board? The main board is that way on. Oh right, so we might have, well, that's just for the keyboard. I think that's alright. I think we've just got another clip on this side, and we'll have it right at the top there, so we can get something to unclip that with. I should do it. There we go. Right, so perhaps we shouldn't have undone the screws for the disk drive, but I felt why is the disk drive stuck? Okay, so we've got that screw there, I think we need to take out. And that should release the disk drive, I think. Take that screw out. Yeah. Now, if I pull out those two cables, that's the keyboard disconnected. Now there's the backup battery, and that fortunately doesn't look like it's leaked at all. That looks in really good condition, that's good. I don't see a hard drive, so yeah, the hard drive's been taken out of it, but that's not a problem. Right. Now the question has to be, it's not going to be that, is it? That that must be power for the screen. That's VGA. So that must be power there. Now can we disconnect? Let's take these two screws out. What I'd really like to do is separate the keyboard and the screen from the bottom of it. And actually, I can't see any capacitors on here that cause major issues. Right, that's the switch mode power supply there. That's what we want to have a look at, because I'm a feeling that might be what's causing the where the issue comes from actually. Right, so snip that cable tie there. Straighten that connection there. Oh no, that comes out like that, that's okay. That was just for that. Right. So is that just the inverter board for the backlight for the monitor, or is that going to produce some of the other voltages we need as well? That is the question. We'll disconnect that because that's something we need to look at. So we've got that is definitely a switch mode power supply board, but is it just creating the power for the backlight for the screen, or does this create some of the other voltages needed on the computer as well? It does look a little bit complicated just for a backlight for a screen, but I'm not sure. It's also got these early 90s Nichicon capacitors. Those two look like they've been running very hot because the plastic shrunk back on them, so we will have to have a look at this board. I think this might be some of our problems. In fact, looking at the rest of the board, in fact what we can probably do, I think we can disconnect gently that, which is the, no, that's ridiculous. They've got a plug connector there for the VGA, and the ground's actually soldered in place. So, oh, what a silly way of doing it. That switch, is that a make or a break switch? That's to indicate whether the screen's actually down or not. I'll have to warm up the soldering iron so we can actually get that off. That's a pain. Just bear with me a sec. There we go. Just warm the soldering iron up and we can disconnect that. We'll disconnect that one. That is the, to that button there on the front. That just indicates whether the screen's been put down. It probably just shuts the computer off. We need to identify whether that's a push to make or a push to break. We'll do that now while we wait for the soldering iron to warm up. Get some probes. This is basically just so we can just power the board up on its own without the keyboard or anything attached. For initial scene, we can actually get this thing up and running. So, got my nice thin probes here. We'll probe in there. We'll probe in there. Right, that's excellent. So that means it doesn't matter, we can just leave that unplugged. It actually sends a signal when it's pushed down. So that's disconnected, that's disconnected. All we need to do is disconnect that ground down there, and we can free the top. In fact, we might even be able to take this opportunity to do some repair work to the plastic on this. Right, let's see if that's warmed up enough. Okay. I should really put my anti-static. Well, I'm on the anti-static. Oh no, I better do. See, we are working inside this thing now. Put the old anti-static on. There we go. There we go. That's better. Right. Okay. Now, where was I? Oops. This won't come off. I'll have to just cut the wire off and then solder it back. Add a little bit of fresh solder, just help it to flow. That might be all it needs. Come on, off you come. I'm going to do more harm than good doing that. We will snip it off like that, and then we can solder it back on after. That's what I mean about the case. Have you seen there's a great big crack right through there, so before I put this back together we can at least do something about that crack there. But now we can concentrate on the actual main board, and there's a few tantalum capacitors on here. There's one there, couple there, one there. Well, obviously we've got a standard charge 3.3 milliamps, so that's actually a rechargeable battery. 3.6 volt rechargeable battery there. It doesn't seem to have any sign of corrosion on it. I'm guessing it's got absolutely no charge left in it, but we'll test that now. Where's my tester? Can't imagine that battery's got any charge left in it, but we'll see. Yeah, a couple of hundred millivolts, that's about it. So yeah, that battery's gone, so it has lost any settings it did have. Like I said, that's not really an issue anyway. I don't think there's actually a problem with this, really. I have a feeling that the actual issue is on that board there. I'm actually looking at all those Nishikon capacitors, especially those two there. What I'll do, I can't see any signs of corrosion on that board. We could have a bad one of these electrolytic, these tantalum capacitors. One of those could be shorted. In fact, sorry, can you just bear with me a second, please? My dog's going absolutely crazy, so I think there's someone at the door, so back in a sec. Right, okay, sorry about that. Now, where were we? Right, I think what we'll do is we'll put this to one side. Put that up there where it's out of the way. Like I said, this is what I think is where the issue lies. Basically, I have a feeling that side there is the inverter basically for the backlight, and this is producing our, all the other voltages we need. At least I think that's what's going to be going on here. I don't have obviously don't have a circuit diagram for this laptop, so I'm just surmising. But I can definitely see those two capacitors have obviously been getting hot because the insulation has shrunk back on them. So what we'll do is we'll pop them out of circuit. We'll pop one out first. It's those 2 points there, I think. Let's have a look around. Yeah, it's those 2 points there. I'll say the Sharpie, something I could just mark them with. So it's those two and those two. Okay. The reason I'm taking these out, these actually look physically, oops, let's keep you in shot. The reason I'm taking these two out is they do seem to have some physical damage to them. In fact, that's quite an unmistakable smell straight away. I can smell electrolyte. Oh dear, yeah. Yeah, these capacitors are definitely leaking. And they might prove to be a bit of a pain to get out of the board, actually. Due to the very fact that the electrolyte has affected the solder somewhat. But I can smell it straight away now. Smell a little whiff when I touch that first leg, but when I've hit this second leg there, the smell is really quite strong. They are desoldering, but it's going to take some time, I think, to get them out. Let's see if we can rock it out. Hopefully you can see what I'm doing there. Basically what I'm doing, I'm just rocking the capacitor as I warm the legs up, and just see if I can rock it out of the board. But there's that unmistakable bad fish smell. I can smell it quite strong now. It's coming, but it's in fact, what I think I'll have to do, just bear with me a second, folks. I might have to actually use a little bit of hot air, warm it up and pull it out that way. So back in a sec. Okay, we've finally got that capacitor out, and that was a right pain in the backside. That's took me about 20 minutes of slowly walking it out. I was going to use hot air, and then I realised we've got that many surface mount components on the bottom of this board. If I used hot air, I risk actually dislodging some of those. So like I said, I just took it easy and just walked it very slowly out of the board, but it did take some time to do that. But it's actually, like I say, it's actually wet on the bottom there. It's definitely a not a very happy capacitor. In fact, I wonder if it'll actually even may be open circuit or just reading as a resistor. Let's see. I don't think it's got a lot of capacitance left in it. No, I don't think that thing's got much much capacitance left in it. What is it? We want a 220 at 25 volts. I'm guessing the other one, yeah, the other one's exactly the same. That's also a 220 at 25 volts. So let's see if I can get this one off a little bit easier than that one. Just make sure it is not yet. It's not actually marked, so you've got to be careful when you're taking these out to make sure you know which way round it goes. I'll have to figure that out after. It's easy enough to do. We can just check from the ground from a easier if I talk without a piece of solder in my mouth. It's easy enough to do. We'll just check from a ground from another capacitor and find out which side's the ground for that one. Let's take this one out and we'll make sure that we know ground's this way. Oh boy, that stinks. Ground towards the transformer. There we go, that one's out. I think that one's actually probably okay, although it does look like it has suffered a little bit of heat damage there. It's not all wet on the bottom like that one was. The seal's blown on the other one. I don't know whether to change the other capacitors in there as well while I'm in here. What I'll do, let's get these holes cleared out. Go. Clean that out. Right, what I'll do, God that stinks, I'll get some isopropyl and we'll clean this board up. I'll find some replacement capacitors and we'll put some new capacitors in there which don't stink of leaking electrolyte. I will have to have a good clean up in there first though. In fact, what I might do is take these capacitors out anyway so I can clean up round them, because that electrolyte will be all over the board. I will just quickly pause the video and I'll see if I can find some suitable replacement capacitors, so back in a sec. Right, okay, we're back and we have a set of replacement capacitors here. Now, they're not brand new capacitors, but they are perfectly good. They have all been tested and those are courtesy of Sky. I find so many discarded Sky boxes and they're always handy because they, generally speaking, contain a 500 megabyte hard drive and loads of useful little components like that. And they do use a fairly decent brand capacitor as well. I think these are Rubicon. So I'll Yep, those are Rubicon capacitors. So we've got a full set of new capacitors. The thing is with this, a bit of IPA. We need to clean all the old leaked electrolyte out, which will have also leaked underneath basically those capacitors as well. And we don't know whether those capacitors are any good. So the best thing we can do is pull them out and to clean underneath them. If we've got them out, we may as well replace them with a newer, a much newer capacitor. To clean where the old capacitors have been. Just get the knock on the rubbish off that. That's okay. Now we said strike, which is negative towards the transformer, didn't we? Just fold those legs in a little bit. That one in. That one goes. Just need to dress these legs so I can get them in the holes. There we go. That goes in that way around. Like that. Oops. That's dropped straight back out again. Let's try that again. In. That one's in. Right, this time we'll just spray them legs out ever so slightly like that, just so the damn thing can't fall back through. That one's holding in quite nicely actually, that one's a bit tighter. Right, let's solder those in place. Okay, there we go. Then we can trim them legs off. There we go. So that's those two changed there. I'll do, because that one looks like it's been getting hot anyway. It could have just been whatever was causing that, but that definitely looks like it's been getting hot. I'm not so sure about the one next to it. But basically what I'm going to have to do now is take those, I'll do them two at a time because it makes, you're going to make less mistakes doing it that way. So we'll take those two out and then we'll replace those two and we'll carry on moving around the board. So I'll come back when I've got a few capacitors done and we can basically see how we're getting on. So back in a sec. I just thought I'd bring you back real quick. We're actually just on this the first capacitor I was saying, which is that one right there. And I think all these are leaky because as soon as I touched the board here with the soldering iron to try and just flow some new solder on these before I got the capacitor out, there's that really strong smell of bad fish. So it looks like pretty much all the electrolytic capacitors on here are indeed starting to leak. Now we managed to get some fresh solder to flow into that, and that's really the key to getting these capacitors off. when they leak like this, it does something to the solder, and the solder doesn't flow like it used to. What we'll try and do, I've got solder basically over both of the pins there. We'll try heating them both up and just see if we can. There we go. And we'll just walk it off the board. Get the excess solder off my iron there. There we go, and that's out. And yeah, you can see that all the bottom of that capacitor is really wet. And we just touch it, and it stinks of bad fish. So again, that one's been that's been leaking. I'll just quick flip over and have a look at the other side of the board. I can't see any obvious damage there. Just a case, like I said, we had a very leaky capacitor. So we'll pull the next one off, and then we'll have a bit of a clean up around the board. So okay, back in a sec. Right, well, we finally got those two out, and again, that was a real pain in the whatnot to remove. But we'll get a new Q-tip. That one's manky. But basically, in there, we want to get rid of all the old electrolyte which is on the board. You can have a look at there. Look at that. You can see it coming off there now. So even though we just suspected it might have been that first one of them first two caps there and there, I am going to change them all, because that, I don't think that second one there was actually leaking, but that first one there we took out was 100% leaking. So we don't want leaking electrolytic capacitors. And I consider that they're 30 years old, they've not done particularly bad. But these Nishicom, these brown ones in particular like that, they are starting to actually physically leak. I found a lot of these in power supplies and things like that that have gone leaky. You find loads of these in Apple, like Apple power supplies and stuff like that, Apple monitors, and they all seem to be going bad. Right, quickly what I want to do is just ascertain which of the pin is ground. If I can use it. Because I remember specifically that that one there is ground. So is it that one? Oh, it should be this one. Yeah, it is. So we want two of those, and this is one of these cases where the new capacitors are actually, although they're exactly the same voltage rating and capacity, they're actually physically slightly smaller than the originals, which does make getting them on the board a little bit easier. What we need to do, we'll spin the board over, we just need to do a little bit of clean up work on this side before we actually add the new components. It'll just make life a bit easier. Ooh, there we go. Get some of the residue from removing the old ones and cleaning the holes out off before we start sticking the new components on. Well, when I say new to this board, I've no problem reusing like components like this. They're off modern equipment that's probably not had a huge amount of use. Looking at how, in fact, most of these skyboxes that I pillage for parts like this, are still in working order. It's just they've been superseded. There's that gone down. Got one leg in and one leg out. Ah, damn, got that stuck then. Let's try that again. There's only one problem you've got, it's damn fiddly to get the new parts back in the board if you're reusing components, because they tend to have shorter legs. This is a lot easier with a brand new component, but I would never do this if I was repairing something for someone, but for when it's just something that's in my collection, so I'm more inclined to use salvage components sometimes. There we go, it's gone. Thank God for that. Right, we'll definitely just bend the legs, make sure that's home, and we will just bend the legs out slightly on the back like that, just so it doesn't drop back out again. Let's have a go at the next one. Now we want the stripe that way on this one. And that went straight in, lovely. Okay, there we go. We'll spin that over and we'll get those soldered in place while they stay where we want them. Is that one done? That one done. That one. And that one there. There we go. And again we'll just snip those legs. There we go. Lovely. So that's those 4 capacitors there has changed. I'll probably do that little cluster around there next, and then we've just got 2 over there and one final one over there. I don't think that one's leaking, but seeing I'm changing all the rest, I might as well change that one while I'm at it. In fact, I won't bore you with that. You've already seen me change a few there. Unless I come up with something interesting, and then I'll come right back. If not, we'll come back when I finish this board and we can actually try it back in the laptop. So back in a sec. Right, we're back, and as you can see, that's all the capacitors now changed. There's all the old ones, and at least over 3/4 of them, actually, when you look at them, are actually physically leaking. So those were definitely part of the problem there. Put them in the bin. I can't say that what I've done will have fixed it, to be fair. We don't, oops, let's get out of it. We don't honestly know. Having leaking electrolytic capacitors like that could have caused other damage to the actual main board. So, well, not to the main board, sorry, to the actual switch mode board there. Which we're not going to know until we actually try it. So I suppose that's what we'd better do now. We'll get the bottom of the computer back in, and we'll get this board connected back up, and then we'll hook some power up to it, and we'll see what it does. Just see if we get any different activity. Now, I think lining this back up on there is going to be fun. No, it wasn't too bad to do that. It took a while. It was quite fiddly. Now, has that gone and lined up with its pins? Oh yeah, get that on there like that, and it can't really go wrong. We'll stick a screw in just in case it needs to ground down to the ground down there. So one of those screws there. We'll stick one of those back in, like I said, just so if it does need some grounding, it's going to get it. We won't bother connecting the screen or anything back. In fact, I wonder if I just connect it up to the test monitor there. I'm pretty sure you'll have to press a key combination actually on the keyboard to get it to work, but it might be worth a try. Plug that in there like that. I've noticed this, that the VGA connection's not. I had to fiddle around last time to actually get the VGA plug to plug in. I don't know why. Well, why is that not plugging in there? I don't know, because it's not as though it's got a pin blanked off or anything, and all the pins are straight there. So why are you being awkward? It keeps dropping out. Well, we can fiddle about with that after. For now, let's just see what happens if we connect some power up to it. We'll use my bench supply that we used last time. Right, now let's make sure we know which one's positive. Right, so that's positive there. We can go. We'll have to go on the inside. I think it's the only way to actually get a good connection. That on there. That on there. So we're basically simulating a fully charged battery just using a bench supply. So that should be okay there. That's okay. Let's switch on. Did you hear that? We'll switch off. And you notice that if you've watched my previous video, when we actually tried powering this up, we actually got a slowdown on the fan speed as though the fan was being really loaded. If I switch on now, oh, hang on. That's what it was doing last time, but you heard that when we first switched on, it actually powered up and we got the beep 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 as though it was actually doing something. So hang on, the floppy drive's trying to do something. Here, the floppy drive seek then. There we go, beep beep beep. Right, so it's definitely doing something. We'll switch off again. Turn off there. I wonder what I'll do. I'll get it a little bit more assembled. We'll get the screen actually connected back up to it, and we'll see if it's actually going to do something. So back in a sec. Right, okay, I've got the computer loosely back together. It's not screwed, it's not actually screwed together or anything. I've literally just got everything plugged back up. We'll switch, and I've got I think I've got some boot discs here just in case we get that far. I'm not anticipating we will, but let's see. Switch on there. Now we are actually getting some activity now. Can you see the backlight starting to flicker? It's not. Hang on. Power light's on nice and solid. But we've got something on the screen then. Is it just like into a boot loop? I'm not sure. It's obviously not happy. Try switching it off again. Well, that's the first time we've actually seen anything actually happening on screen. Try switching on again. again, it's pulling that screen. It's actually pulling the power supply down. I wonder if we just can't pull the current. Well, I can't see that being the problem actually. But it shows it's not completely dead. Like I said, the computer isn't totally dead. We have got a little bit of activity there now, which is more than we had before we started. I wonder actually if I disconnect that CMOS battery. So I'm wondering if it's that bad. It's actually shorted out and it's turn off. I'm just going to reach in and try and actually disconnect the CMOS battery completely from the main board, because I'm wondering perhaps if it's, I think it's an old Nikon, whether it could have actually shorted out internally, and that's actually one of the problems. Let's try again now. It's certainly, we know it's no voltage on it. No, just the same. Let's try. We'll try switching it on with the power supply rather than the on switch, because that's what we did at first, and it actually did start to fire up like that. We'll let it run and we'll see if anything. You've got a beat. No, it's still not happy. But we certainly have made more progress than we did when we first initially started to try and power this thing up. So we know we definitely had some issues on that power supply board, but it does look like we've got other issues with this computer. Anyway, I'm going to leave it there for now. So I weren't really planning on doing a restoration or a repair on this computer yet. But after I made that video the other day, kind of like got the better of me thinking about this. I thought, I just wonder, you know, is it going to be capacitors inside? And yeah, we found out it really was. Obviously we'll do a part 2 on this video. Obviously we need to do something about the case, because the case is in a shocking state. And hopefully we can see if we can actually get this thing to possibly boot. We do have some signs of life on it now at least, so we know it's not completely dead. We need to see if we've got some sensible voltages coming out of that power supply now, and then take it on from there. But hopefully, fingers crossed, we might actually be able to get this thing working again. Anyway, I'm going to leave it there for now. I hope you enjoyed this little update on this project. So thanks for watching and goodbye.